Hello everyone, my name is SushiNT, and today we're going to be doing some chemistry. I did not mean for that to rhyme, but anyways, I got my periodic table here. Simple thing, just kind of telling which blocks I coordinate to each element, and then I have little general trends. I still need to put electronegativity on it, but general trends of the periodic table. But today, what I really wanted to do is help visualize SN2 and E2 reactions using the 3D space of Minecraft. So what here I have, let's see, we have 1, 2, 3, 4, 5 carbons, and it's on the second carbon. So we have two, let's say green. I usually try to make them pretty obvious. So yeah, green is chlorine. So here we have chlorine on the second carbon, so it's 2-chloropentane. And then, of course, we have all the hydrogens coming off, which are these. The green ones are hydrogens. And then this is just supposed to kind of symbolize the sharing of electrons between the atoms. As much as I would like to make a complete render of like how the electrons actually would be, they would be shared. So this one would be going around this atom, and this one would be going around this atom, and they'd be all around each atom, but that's kind of hard to show. So I use this in like the line diagram to show that. But up here we have a nucleophile, which is sodium, sulfur, and a hydrogen, so NaSH. And SN2 stands for bimolecular nucleophilic substitution. So this nucleophile is going to want to come in to this carbon because this chlorine, and the reason it doesn't want to go to any of these other carbons is because the chlorine is very electronegative. It really likes its electrons. It's a bigger molecule and it wants more electrons, so it's going to shift. There's going to be a dipole on this carbon where it's going to shift the electrons more towards this chlorine, making this carbon partially positive or wanting more electrons. So what's going to happen is this sulfur, which the reason it's going to start attacking from the back is because this chlorine is in the way. So you would see this as a, it's coming towards us. So you'd see it as a wedge if you draw it, filled in wedge. And then this hydrogen would be on a dashed line. I'll make a picture of it and put it on so it makes more sense. But this sulfur, and it's going to come in and attack from the back. It's going to flip this hydrogen around. It's going to push the hydrogen out of the way. And then it's going to attach to the carbon. And then the sodium ion that was on this sulfur is going to get kicked off. And it's going to go bond with the chlorine because sodium and chlorine, salt really likes to bond together. So they're going to bond. And then this is your finished product where you have your sulfur hydrogen on the opposite side of where you had your chlorine, and then your chlorine is going to come and bond most likely with the sodium, and then this is your SN2 reaction. Okay, so that was SN2. I know the animation was a little janky. I could probably work out some bugs, but you get the gist of it. I think it helps visualize what's going on. But second one I thought would be neat to show is a E2 reaction or an elimination reaction. So let me start it. We have, oh my gosh, let's see. We have three carbons, and then on the first group we have an iodide group, and then we have a benzene ring, and then we have a methyl, or a carbon with 3 hydrogens coming off. And then here we have DBU. I don't remember what it stands for, but it's just this big bulky base. So, very, very large, and then these should be nitrogens. So what's going to happen is usually with E2 reactions, you want the hydrogen that's being taken off and the group that's getting eliminated to be on the same plane of field. So this molecule is going to rotate and make sure that the iodide and the hydrogen that's being eliminated are on the same plane. So you see now, we'll wait for it. So the hydrogen, the one that's being eliminated for the E2 reaction, and the iodide group are now on the same plane. They're no longer on opposite planes. They're same plane now. And then, oh, we switched around for a second. What's going to happen is this big bulky base is going to come up, and the double bond on the nitrogen is going to want to grab this hydrogen. So the electrons are going to come over, grab the hydrogen, and then the electrons are going to form, or from the hydrogen bond, are going to form a double bond with this carbon, and then the carbon is going to kick off the iodide group, and then there you have it. There's your E2 reaction, and here's what each molecule looks like afterwards. I don't know. I think it's helped me figure out how the reaction mechanisms work in 3D space, because dashes and wedges, just kind of on line paper, you can't really work in 3D. So when you have a space like Minecraft, it's much easier to kind of visualize, like, okay, here's what's happening and here's why. Last but not least, we have SN1 reaction. So we have a, let's see, 1, 2, 3, 4. So a butane, and we have a methyl group on the second carbon. And then we have a, oh gosh, okay. We have a bromine, and then what was that? Was that nitrogen, or was that something else? I gotta keep checking my periodic table. That's oxygen. Okay, so blue is oxygen. So we have an oxygen. Okay, we have an alcohol then. We have an OH group, an alcohol, and then we have this bromine right here. Was this supposed to be on here before? Did I do the, oh my gosh, 1 second. Okay. We'll play it through real quick. So in SN1, there's a carbocation intermediate. So yeah, okay. Let me reset this real quick. So it might have skipped a step because it was a little too fast. Let me quickly, there we go. Okay. So I think it's missing a step, but this bromine was connected to here, and then bromine is a really good leaving group, so it's just gonna leave. It's gone. It's going bye-bye, and it's heading on its merry way. So this leaves this with a positive charge, because this bromine kind of just stole the electron that was on this carbon. So this bromine grabbed its electron and just dipped, and this oxygen, which is very electronegative. Oxygen is, more on the right of the periodic table. So it's very electronegative. It's going to see this carbon cation, and it's going to want to come in here and grab it. So it's going to come. The hydrogen is going to flip up, because that's the best stereochemistry for this molecule. And what's going to happen next is, because there's more than just one of this molecule. There's more than 1 to 1. Another one of these molecules of oxygen with 2 carbons coming off of it that could have had its hydrogen removed is going to come in and grab the hydrogen that was on this oxygen. And then you have your SN1 reaction, where now you have your oxygen bonded to whatever this molecule was before. And there you have it. I know these reaction mechanisms aren't the most robust, but they work and they help to visualize what's actually going on. And that's why I've been making them, is to help me visualize kind of what's happening in these reactions. But those are the only ones I've coded so far. The rest is yet to come. Anyways, I hope you guys enjoyed the video, and I'll see you in the next one. Bye.